I am Mr. Vishal Pawar, working as an assistant professor in Department of Chemistry, PG. Today we are going to see one topic from the subject CHO 352, Stereochemistry and Asymmetric Synthesis of Organic Compounds of class MSc 2nd, Organic Chemistry, semester 3rd. The name of topic is Elimination Reaction. If you consider a general elimination reaction, let's say for a reaction between an alkyl halide and a base, the rate determining step involves an interaction between the base and the alkyl halide. If you look at the reaction, the base react with the alkyl halide, there is an elimination of halogen takes place. The reaction takes place in a concentrated way. Concentrated way meaning that the base pick up the hydrogen and simultaneously there is a formation of the carbon-carbon double bond with the loss of halogen. These steps they are taking place in a concerted manner or simultaneously, and there is a formation of base BH plus olefin plus halide ion. This is the general elimination reaction. Now, if you consider the dehydrohalonation reaction, dehydrohalonation means loss of hydrogen halide. If you consider a general reaction, hydrogen halide with say lead hydrogen such as chlorine, bromine, iodine, when react with the strong base, there is a formation of carbon-carbon double bond, that is olefin plus hydrogen halide. In a cyclogen ring, the E2 elimination reaction proceeds best when atoms or groups to be limited are trans-diaxial to each other. This is a stereoelectronic requirement of the E2 elimination reaction. Now, as we have seen the general reaction, now we are going to apply the concept of the general reaction with that of the cyclogen ring. As in case of cis elimination, the stereoelectronic requirement is that atoms or groups to be limited, they must be cis to each other. But in case of A2 elimination reaction, the stereoelectronic requirement is that atoms or groups to be eliminated, they must be trans-diaxial to each other. Then only then the A2 elimination is possible. Remember this stereoelectronic requirement. Now consider one of the example. Let's say dehydrohalonation of the methyl chlorides by base. Consider a question regarding this topic. Question is like this one. Neomethyl chloride undergoes base catalyzed dehydrochlorination about 200 times faster than methyl chloride. Here we are going to consider two isomers of methyl chloride. One is methyl chloride, another is neomethyl chloride. And look at the question here. Neomethyl chloride undergoes base catalyzed dehydrochlorination. Here we are going to see loss of HCl. Now question is that why neomethyl chloride undergoes 200 times faster elimination than methyl chloride? The explanation for this one we are going to see next slide. This reaction is an example of E2 elimination reaction where the atoms or groups to be limited are trans-diaxial to each other to fulfill the stereoelectronic requirement of the E2 elimination reaction. As we have already seen in previous slide that the stereoelectronic requirement of E2 elimination reaction. Now apply this concept to the dehydrochlorination of methyl chloride here. These are the two structures of methyl chloride and neomethyl chloride. In case of neomethyl chloride, the methyl group is beta, chlorine is alpha, and isopropyl group is also alpha. While that in case of methyl chloride, The methyl and chlorine group, they are having the beta orientation, and isopropyl group having the alpha orientation. Now consider first of all new methyl chloride. If you consider the methyl, chlorine and isopropyl substance, they are placed at 1, 3 and 4 position respectively, having beta alpha alpha orientation. When new methyl chloride undergo reaction with sodium ethoxide in presence of ethanol, that is base, there is a formation of two products. The first one is a 2-methene and the second one is a 3-methene. Out of these two one, if you consider stability of these two, 2-methene which is less stable and 3-methene which is more stable. According to the Set-Jep rule, more saturated olefin is obtained as a major product. As 3-methene is more stable, which is more saturated one. Okay, and if you consider the percentage in this one, 2-methene is formed as a 25% and 3-methene is formed as a 75% as a major product. Why this is so? And that we'll consider in next slide. Now in this one, if you consider methyl chloride, the methyl, chlorine and isopropyl substance are placed at 1, 3 and 4 position, having beta, beta and alpha stereochemistry respectively. When they react with the base, there is a formation of only one product, 2-methene, about 100% one, though it is less stable one, which is formed as a major product. Why this is so? That we will also consider in subsequent slide. In the dehydrogenation of the methyl chlorides by base, new methyl chloride readily loses the elements of hydrogen chloride to give 2-methene 25% and 3-methene 75%, whereas methyl chloride reacts at a very slow rate to give 2-methene 100% only. Now consider first of all new methyl chloride. In new methyl chloride, the leaving group halogen, that chloride, is present at the axial position. With respect to that axial position, there are two anti-hydrogen present corresponding to this leaving group chlorine. The first one is the Ha hydrogen and second one is the Hb hydrogen. If you consider first of all removal of Ha hydrogen minus HCl, there is a formation of olefin, the first one. And if you consider the loss of HbCl, there is formation of the second olefin. Okay. So reaction can follow either route to give the two products. Now the question remains that which is the major part in this case? The more stable conformation of new methyl chloride is one in which the chlorine is axial and there are axial hydrogens on both C2 and C4, that is Ha and Hb hydrogens. Hence the new methyl chloride gives rapid E2 elimination, forming both 2-methene 25% and 3-methene 75%. Now in case of methyl chloride, no anti-hydrogen for elimination because the leaving group chlorine is at equatorial position. That's why for doing the E2 elimination reaction, we have to satisfy the stereophonic requirement. For that purpose, we have to do the flipping or ring inversion. After ring inversion, the equatorial chlorine becomes axial one, and with respect to that axial, you consider that conformation after ring inversion. All the three substances, they are at the axial position, and before ring flipping, they are at the equatorial position. That's why in this case, the less favorable conformation is formed by the ring flipping. Okay, because all the three substances, they are at axial position having the steric crowding. Therefore, in this case, only one axial hydrogen at the adjacent position having the anti-orientation with that of chlorine undergo removal to form only one product, that is we get this olefin. But as this product is formed from the unfavorable conformation. Remember that one. In methyl chloride, there is no antihydrogen for elimination, but after ring flipping, there is only one antihydrogen for elimination, and hence we get only one product. Point to note that although the flip conformance is very higher energy and hence percentage population is very less, but once the reaction starts, equilibrium drives towards the product. For methyl chloride, E2 elimination is much slower because the unfavorable conformation had to be achieved before elimination could take place, and the product is 2-methane 100% because on this side there is axial hydrogen. Thank you.